Hello everyone, welcome back. Today we're going to talk about solving exponential equations. Let's start with this first one here. It says 3 to the power of 2x is equal to 27 to the power of x minus 1. Now, because 27 can be rewritten as 3 cubed, I'm going to do that first and rewrite this. So we're going to get 3 to the power 2x is equal to 3 cubed to the power of x minus 1. Then for my next step, I'm going to apply the power to a power exponent law, and we're going to multiply 3 by x minus 1. We're also going to use the distributive property here. So we're going to get 3 to the power 2x is equal to 3 to the power of 3x minus 3. Now that our bases are the same, we can just solve for the exponents, right? This means that 2x must be equal to 3x minus 3. If I subtract 2x from both sides, I get that 0 is equal to x minus 3. And then if I add 3 to both sides, I get that x is equal to 3. And so that's the answer for our first one. Okay, so for the second one, we have 7 to the power of x is equal to 14 to the power of x minus 1. And so we need to express 14 as the same as 7 times 2. So let's do that. 7 to the power x is equal to 2 times 7 to the power of x minus 1. Then recall that whenever we have a product to a certain exponent, that we must take both parts of the product individually to that exponent. So therefore, this is the same thing as 2 to the power of x minus 1 times 7 to the power of x minus 1, like that. Then in this case, we need to divide both sides by 7 to the power of x minus 1. So if we do that, we end up with, on our left side, 7 to the x over x minus 1. Recall that whenever we have two exponents of the same base, we subtract the bases. So we would get, on the left side, 7 to the power x minus x minus 1 is equal to 2 to the power x minus 1, because keep in mind these just cancel. Now what is x minus 1? Well, that's going to be x minus x plus 1 once we use the distributive property and distribute the negative into both. So then we're going to get 7 to the power 1, which is just 7, is equal to 2 to the power of x minus 1. Now it's at this point that we must take the ln. So let's ln both sides. If we ln both sides, we're going to end up with ln of 7 is equal to ln of 2 to the power of x minus 1. And then because we've ln'd it, based on our ln and logarithm laws, we can put x minus 1 out in front. Therefore, ln 7 is equal to x minus 1 times ln 2. And now we need to solve for x. So I need to divide both sides by ln 2. If I do that, I will get that x minus 1 is equal to ln 7 over ln 2. And then if I add 1 to both sides, I will get x is equal to ln 7 over ln 2 plus 1. So at this point, if the question just wants the exact answer, we would stop here and say this is the answer. It's ln 7 over ln 2 plus 1. If they want a decimal approximation, like let's say they wanted to 2 decimal places, then we're going to grab our calculator, type in ln 7 divided by ln 2 equals, and then plus 1 equals. And then I'm getting about 3.8 when I do that. So this is approximately 3.8, or actually we said 2 decimal places, so we'll go with 3.81 since the actual value is 3.807 and then some other stuff. So the 7 does allow us to round that 0 up to a 1. And there's our answer. Okay, so the next question is e to the power of 2x is equal to 20. Now, the thing we need to do in order to get rid of the e is we need to ln both sides, because ln e is, they cancel out, right? Because they're reciprocals. Ln and e are opposites in that way. So I'm going to ln both sides, and we're going to get ln e to the power of 2x equals ln 20. Then in the next step, ln and e cancel out, and we just get 2x is equal to ln 20. Then we can divide both sides by 2 to get that x is equal to ln 20 over 2. And if the question wants the exact answer, we would just leave it like this. We say, well, that's the final answer. It's ln 20 divided by 2. However, if they want a decimal approximation, we're going to grab our calculator, type in ln 20 equals, divide by 2 equals, and we get about 1.5 approximately. 1.50 if we were to round to 2 decimal places there. Awesome. Okay, let's try the next example, which is this one here. What if we have 2 to the power x is equal to 7? Well, first thing we need to do is we need to figure out how are we going to get the x out of the exponent. And so we're going to change this into ln form as well. So ln 2 to the power x is equal to ln 7. Then I'm going to put the x out in front, right? Because recall that for all logarithms, including the natural logarithm of ln, we can put x in the front when we have it as the exponent. So therefore, we have x times ln 2 is equal to ln 7. Then if we divide both sides by ln 2, we get x is equal to ln 7 over ln 2. And again, if they want the exact answer, then that's just the answer. It's just ln 7 over ln 2. If we want a decimal approximation, we grab our calculator, type in ln 7 divided by ln 2 equals, and I get about 2.81 approximately, if I round that to 2 decimal places. Okay, let's do one last one. Okay, this one is 100 to the power x is equal to 1/10 to the power of x minus 3. Now here's the great thing. I can write 1/10 in terms of, I can write one of these in terms of the other one, or I could switch both to just base 10. We know that 10 squared is equal to 100, so I'm going to replace 100 with 10 squared. And then 1/10 is the same as 10 to the power of negative 1. So I'm going to replace 1/10 with 10 to the power negative 1. Now let's recall that whenever we have a power to a power, we multiply the power. So therefore, 10 squared to the power x is equal to 10 to the power of 2 times x, which is 10 to the power of 2x. And then here we have 10 to the power of negative x plus 3, like that, because I'm going to be multiplying negative 1 with x minus 3, right? Since when we have power to a power, we multiply those powers. Now we have that 10 to the power 2x is equal to 10 to the power of negative x plus 3. So that tells us that 2x must be equal to negative x plus 3. If I add x to both sides, I get that 3x is equal to 3. And if I divide both sides by 3, I get that x is equal to 1. And so that's our final answer here, that x is equal to 1. All right, very good. Any questions about any of that, please leave them in the comments, and we'll see you for the next one.